Okay, hi students. Now we are going to go ahead and talk about the next kind of sequences that are also a part of arithmetic sequence, but they are called as quadratic sequence. Now if you see here, we're talking about quadratic, right? Quadratic, as I had explained you in my previous class about the power of n to be 2, right? So when you have your nth term that has a power of 2, alright, then you say it's a quadratic sequence. Now how do you identify if it's a quadratic sequence? If you see here, let's talk about taking an example. If I can you see the cursor here? Alright. Now let's take an example here. If you see 2, 6, 12, 20, 30, 42. Now if I find the differences, I can see it's plus 4, then you have plus 6, plus 8, plus 10 and plus 12. If you see, the first time that I find the difference, I am not getting a common difference because that's the basic difference between a linear sequence and a quadratic sequence. In the linear sequence, you are able to get the common difference in the first difference that you find, in the first method that you find. But in a quadratic sequence, you get the common difference in the second method. Alright, am I making myself clear? So, since it's a quadratic, since the power of 2, you need to go 2 steps to be able to find out the common difference. Now, when we are going to go ahead and find the nth term of a quadratic sequence, how do we go about it? Alright, in order to find the nth term of a quadratic sequence, let's say we have this as an example. So I am going to go ahead and find the first difference. Now this difference is also called as delta 1. Alright, I'm sure you know how to write a delta. Delta is written as a triangle and 1. The first difference, if I find out 5 minus 2 is 3, 10 minus 5 is 5, 17 minus 10 is 7, 26 minus 17 is 9. Now if I want to go ahead and find the second term, when I go and do that, I'd see 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So this tells me that when the second difference is common, it's a constant, then I say it's a quadratic sequence. Alright? So a quadratic sequence can be identified when you get a constant, a same common difference in the second difference. Alright. Now, once we have found this, once we have made this table, alright, we need to identify as to how to find our nth term of a quadratic sequence. Now, the general term of a quadratic sequence, if you know, is written as something like this. Yeah. So a quadratic sequence, the general term is written as an square plus bn plus c. So when we have to find out the nth term of a quadratic sequence, we need to find what is a, what is b, and what is c corresponding to the sequence that has been given to us. Alright, so let's just take an example and see how do we go about it. So if you see here, we first found out the first difference, then the second difference, and so on. It's also the same thing here, and that's how. But now, if we're talking about this as being the general term, then the first position, what is the value of n? 1. So n a into 1 square plus b into 1 plus c will give me a plus b plus c. Similarly, what would be the second position? N would be 2. So 2 square a, that is 4a, plus 2 into b, that's 2b plus c. Similarly, if the third position n is going to be 3, correspondingly we have 9a plus 3b plus c. Now why are we doing this? The reason behind doing this is to identify when, if I am talking about a general term, not one specific sequence. If I'm talking about a general term, how does it look like when we take the first difference and the second difference? Based on that, we are going to be able to find our A, B's and C's. So now once we find the difference, we get 3a plus b. For the next one, we get 5a plus b. Now once I go ahead and subtract them together to find the second difference, I'm going to get 2a. Now this particular portion, the whole method that we have done, if I go ahead and just compare it with the question that I had previously. Alright. Now when I compare this, what I can see here is this 2a is equal to 6. Yes, a plus b plus c is equal to 3. 3a plus b is equal to 1. And 2a is equal to 6. So, once we have identified this, we just substitute it to be able to get the values of a, then b, and then c. Let's see how. So, 6 is equal to 2a. Now, we get 1 is equal to 3a plus b, and 3 is equal to a plus b plus c. So now we're going to find out the value of a. If 6 is equal to 2a, therefore a is equal to 3. Substitute the value of a in the second equation, that is 3a plus b. Now once you do that, you are going to get b is equal to minus 8. So I can just go ahead and put b here. After that, I have the value of a and b. I just substitute it here. I get my answer as c is equal to 8. And then I substitute it. So now I have been able to get my nth term of the sequence that I had talked about, and which is 3n square minus 8n plus 8. Alright, now let's take one more example. Okay, let's say we are going to take up this 2, 5, 10, 17, 26. Alright, now I'm just going to make it a little and I'm going to keep this here. So we get 2, 5, 10, 17 and 26. Alright. Now I know that 2a is equal to 2. Therefore, a is equal to 1. Now my general formula is a n square plus b n plus c. So I've got the value of a, which is 1. After that, what did we find out in this example? That 3a plus b is the second one. Therefore, we have 3a plus b gives us this, the first one, right? Which is 3. So when I substitute the value of a as 1. It is going to be 3 into 1 is 3. So 3 minus 3 is 0. Therefore, I have the value of B is equal to 0. So B is 0. Now, post that, what did we remember? That A plus B plus C is the first term. So then we have A plus B plus C gives me the value of 2, right? This one, this was there, and this was it, right? So this is 2 here. Now I have the value of A as 1 plus 0 plus C gives me 2. So C is equal to 1. So now I've got my A, B and C. So my final nth term is going to be n square. Since this term is 0, therefore the whole term becomes 0. N square plus 1. And that is our nth term for this sequence. So I hope you've understood. Now I will be posting a worksheet on Edmodo and I hope you are able to solve them. Any queries, please do let me know. See you. Bye.